The universe is filled with mysteries. Black holes warp space and time, galaxies collide in spectacular displays of energy. But here on Earth, a new kind of wonder is emerging, the rise of thinking machines. We once imagined artificial intelligence as the stuff of science fiction. Now it's becoming part of our daily lives. Our phones recognize our faces, our cars can practically drive themselves, and online algorithms predict what we want to buy, watch, and even believe. This revolution is powered by machine learning, a branch of artificial intelligence that allows computers to learn from data without explicit programming. Machine learning algorithms work by using data to improve their performance on a given task. The more data they receive, the better they become. This is not just about making our lives more convenient. Machine learning has the potential to solve some of humanity's greatest challenges. Join me now as we journey into the fascinating world of machine learning. Machine learning, at its core, is about recognizing patterns in data. Just as our brains find order in chaos, these algorithms sift through vast amounts of information to identify meaningful connections. Think of it like this. Imagine trying to teach a computer to recognize a cat in a picture. With machine learning, you can simply show the computer thousands of images of cats and let it figure out the defining characteristics on its own. This ability to learn from data is what sets machine learning apart from traditional programming. Now let's delve into the different types of machine learning and how they shape our world. Supervised learning is like having a teacher guide you through a new subject. You are given a set of labeled data, where the input and the desired output are already paired. The algorithm learns the relationship to predict outputs for new inputs. Imagine teaching a child to identify fruits. You show them an apple and say, "This is an apple." Then you show them an orange and say, "This is an orange." Over time, the child learns to distinguish fruits by features. Supervised learning algorithms work similarly. They are trained on labeled data sets to map inputs to outputs. This method is used in applications from spam filtering to medical diagnosis. Unsupervised learning is like exploring a new city without a map. You have no directions, no guide, just your own observations to rely on. Similarly, in unsupervised learning, the algorithm is given unlabeled data and tasked with finding patterns and structures on its own. Imagine you are a scientist studying a new species of bird. You have collected hours of audio recordings of their songs, but you have no idea what the different calls mean. By analyzing the patterns in the sounds, their frequency, duration, and variations, you might be able to identify distinct call types and potentially even infer their meaning. Unsupervised learning algorithms excel at uncovering hidden structures in data. This makes them valuable tools for tasks such as customer segmentation, anomaly detection, and data compression. Unsupervised learning opens up a world of possibilities for discovering hidden knowledge and insights from raw data. Reinforcement learning is like learning to play a video game. You start by taking random actions, observing the outcomes, and gradually developing a strategy to maximize your rewards. Similarly, an agent learns by taking actions and receiving feedback in the form of rewards or penalties. Imagine a robot learning to navigate a maze. It starts with no knowledge and receives negative rewards for wrong turns. Positive rewards come when it finds a path closer to the exit. Through trial and error, the robot learns the optimal strategy. Reinforcement learning has enabled AI to defeat champions and control robots in complex environments. Building a successful machine learning model is not a one-step process. It's a journey that involves multiple stages, each crucial for ensuring the model's accuracy, reliability, and effectiveness. Think of it like baking a cake. You wouldn't just throw all the ingredients together and hope for the best. You follow a recipe, carefully measuring each ingredient, mixing them in the right order, and baking the cake at the correct temperature for the right amount of time. Similarly, building a machine learning model requires a structured approach. The first step is to clearly define the problem you want to solve and identify the relevant data you need. This data then needs to be collected, cleaned, and pre-processed to ensure its quality and consistency. Next, you choose a suitable machine learning algorithm, train it on the prepared data, and evaluate its performance. Building a successful machine learning model requires a structured approach and continuous refinement. Data is the lifeblood of machine learning. Just as a car needs fuel to run, machine learning algorithms need data to learn. The quality, quantity, and relevance of the data directly impact the model's performance. Imagine trying to train a language translation model using only children's books. While the model might learn basic vocabulary and grammar, it would struggle to translate complex texts or understand nuances in language. Similarly, the data used to train a machine learning model determines its capabilities and limitations. High-quality data is accurate, consistent, and representative of the real-world scenarios the model will encounter. The quantity of data is also crucial, as models generally perform better with more data to learn from. Finally, the data needs to be relevant to the problem being solved. Collecting, cleaning, and preparing data is often the most time-consuming part of the machine learning process. High-quality data is essential for training effective and reliable machine learning models. Once you have prepared your data, the next step is to train the machine learning algorithm. This is where the magic happens, as the algorithm learns from the data and builds a model that can make predictions or decisions. Think of it like teaching a dog a new trick. You show the dog the desired behavior, reward it for performing the trick correctly, and correct it when it makes mistakes. Through repetition and reinforcement, the dog eventually learns the trick. Similarly, training a machine learning algorithm involves feeding it the prepared data and allowing it to learn the patterns and relationships within the data. The algorithm uses a process called optimization to adjust its internal parameters, gradually improving its ability to make accurate predictions. The choice of algorithm depends on the specific problem you are trying to solve and the type of data you have. Training a machine learning algorithm is like teaching a student, guiding it to learn from data and make accurate predictions. One of the challenges in machine learning is finding the right balance between fitting the training data well and generalizing to new, unseen data. Overfitting occurs when a model learns the training data too well, capturing even the noise and random fluctuations in the data. This can lead to poor performance on new data as the model has essentially memorized the training set instead of learning the underlying patterns. Imagine a student who memorizes the entire textbook for an exam, but struggles to answer questions that require critical thinking or apply the concepts to new situations. Overfitting is a common problem in machine learning, especially when dealing with small or noisy datasets. It can be mitigated by using techniques like regularization, which discourages the model from becoming too complex, and cross-validation, which involves testing the model on multiple subsets of the data to assess its ability to generalize. Finding the right balance between fitting the training data well and avoiding overfitting is crucial for building models that can make accurate predictions on new, unseen data. As we stand on the precipice of a new era, the future of machine learning shimmers with potential. Imagine a world where diseases are diagnosed before symptoms even arise, where personalized education caters to each student's unique learning style, and where renewable energy powers our cities, all thanks to the power of AI. This is not just science fiction. Researchers are already developing machine learning algorithms that can detect cancer cells with remarkable accuracy, personalize learning experiences based on individual student needs, and optimize energy consumption in smart grids. However, this future is not without its challenges. As machine learning becomes more powerful, it's crucial to address ethical concerns surrounding bias, privacy, and job displacement. The future of machine learning is a shared journey, one that requires collaboration between scientists, policymakers, and the public. By embracing both the potential and the challenges, we can shape a future where AI empowers us to solve our greatest challenges and create a brighter tomorrow. We are living in an extraordinary time, witnessing the dawn of a new era where machines can learn, adapt, and even surpass human capabilities in certain domains. Machine learning, the driving force behind this revolution, is transforming our world in profound ways, from the way we communicate to the way we solve complex problems. As we have explored in this journey through the world of machine learning, this technology has the potential to revolutionize countless industries, improve our lives, and help us address some of humanity's greatest challenges. However, it's crucial to remember that machine learning is a tool, and like any tool, its impact depends on how we choose to use it. By understanding the principles of machine learning, embracing its potential, and addressing its challenges responsibly, we can harness its power to create a brighter future for all. Let us embrace the dawn of this new era with curiosity, responsibility, and a shared commitment to shaping a future where AI empowers humanity to reach for the stars.